Hey everyone, happy Thursday. I hope you guys are excited for the 4-day weekend. I certainly am, and I hope you guys are all doing well. Today we're going to look at how we can use collecting gas by bubbling it through water to help us in determining the mass percent of a compound in a mixture. Okay, and so we're going to use that technique to kind of help us do that. And so let's look at this problem. So we have going to place a 1 gram sample of a mixture, and in this case our mixture is going to be of KCl, KClO3 and NaCl. And we're going to mix that together and put it in a test tube, and we're just going to put a gram of that in there. Now what's important to know about this mixture is that when you heat it, okay, potassium chlorate, KClO3, will actually decompose. And when it decomposes, it'll decompose into KCl and a oxygen gas. Now notice that both KClO3 is a solid, the KCl is a solid, but O2 is a gas. And so we're going to see that we're going to be able to release a gas. The other interesting thing about this is that when we have our NaCl and we try to heat that up, it does not decompose at all under these conditions. We'd have to heat it up really, really high to get it to decompose. Okay, and so in this particular situation, as we heat the KClO3, it will decompose, but the NaCl will not. And so what we're going to do is, because the KClO3 is producing a gas, we're going to use a technique whereas we can collect that gas and record the volume of that gas and then figure out what that is. And so we're going to have a little setup here like you see here in the video. Okay, we basically have our test tube that's set up. We have a line that goes from a test tube that goes into a graduated cylinder. The graduated cylinder itself is filled up with water. Okay, and then we're just going to bubble the gas through it. Let's say that in the room currently when we're doing the experiment, we were able to measure and we saw that it was 25.0 degrees C and we had an atmospheric pressure of 1.00 atm. So we're just going to make it easier on ourselves. Okay, so there's where we are. And we know that we put in 1 gram. Okay, and so let's go ahead and take a look about what's going to happen. Okay, so we put in our KClO3. We can see that it will decompose according to that equation, and then we're going to start heating it up. So we start to heat it up, and as we heat it up, right, we can start to see over here, if we watched the graduated cylinder, that our oxygen gas is starting to be bubbled up through that, and the oxygen gas is coming up. So we're going to continue to heat it until all the bubbles go away. And at this point, we see the bubbles have all stopped. And if we read that, we see that we were able to collect 15 milliliters of O2. Okay, so now here's the thing, right? You may be thinking, oh sweet, now we have this, a temperature, we have a pressure, we have a volume of gas. So hopefully you're thinking, oh, PV equals nRT. Sweet, we can do that. Now here's the problem though, is remember we talked about this before, is that anytime that we collect a gas by bubbling it through water, we have to pay attention to something, because the only thing in that graduated cylinder we would hope would be O2, but that's not necessarily the case. Okay, so if we kind of take a look a little bit more at the video, okay, we're going to look inside that container and see what's actually going on. And as we know, if we look inside that container, right, we can see that we have both some oxygen molecules, but we also have some water molecules there, right? So those water molecules and some oxygen molecules. And so we actually have two types of molecules around there bouncing around. And so in that particular case, the total pressure in there is going to be equal to the P of the H2O that's bouncing around plus the P of the O2 that's bouncing around. Now the total pressure is that 1 atm that we saw up here. Now in order to do this, what we need to be able to know, if we need to know the pressure of O2 because that's what we want to use here in our gas law because we're just concerned about the O2, we need to know what the pressure of the H2O is. And fortunately, the pressure of the H2O that's in there is solely going to be dependent on the temperature. And so if I can look up on a chart and see at 25 degrees C, the P of the H2O is going to be equal to 23.8 millimeters of mercury. Okay, and so now we see, well, if we know P total is equal to 1.0, and then P of the H2O is there, but that's 1.0 atm, so we have to convert that into 760 millimeters of mercury. We do that conversion, and then we can see that, well, the P of the O2 then is going to be equal to the 760 minus my 23.8, and when I do that, we're going to see that that's going to give me 736.2 millimeters of mercury. And if I were to convert that back into atmospheres by dividing that by 760, then that's going to be 0.969 atm. So now I know that the pressure of the O2 is there. And so when I know that, now I can go about figuring out how many moles of oxygen gas I actually was able to produce. And again, to do that, we're just going to use our PV equals nRT. So we know N is going to be equal to PV over RT. Now we know that my pressure is 0.6, I lied, is 969. My volume here is 0.015 liters because I collected my 15 milliliters in my container. Divide that by 0.0821 and multiply that by my 298, and that's going to give me 0.000594 moles of O2. So I had that many moles of O2 bouncing around in my container that I collected, so in that 15 milliliters. So now I'm going to be able to use that. So 0.00594 moles, and now I can multiply that by my mole ratio, because what I want to be able to do is, well, the only source of the O2 was my KClO3, and so again, there's 2 moles for every 3 moles produced. That's going to give me 0.000396 moles of my KClO3, and then that 0.000396 moles, and then I know its molar mass is 122.55 grams for every 1 mole. And in that container, I had 0.0485 grams of KClO3. All right, so if I come back over here in my original mixture, I know that I had 1.0 grams of the mixture, and I figured out that in that mixture I had 0.0485 grams of KClO3, and the rest of it had to be then my NaCl. So if I want to know my mass percent, remember mass percent is part over whole. And so if I do part over whole, I have my part here. My whole is 1.0 grams, and I multiply that by 100, and that's going to give me my 4.85%. So that is the mass percent of the KClO in that particular mixture. And that's what I'm able to do by doing my experiment where I just bubbled and collected that gas as it bubbled through water. Okay, I hope that makes sense. All right, there are a couple problems that I want you to work to kind of get used to this and being able to, you can take into account water vapor when you collect a gas over water. So make sure you do those problems and make sure you do your daily task. All right, guys, have a great weekend, and I will talk to you on Tuesday. Peace, love, happiness. Thanks for playing.